it says preparing live stream webinar, and it always gets me and does it. So I'm not going to talk. Okay, you're live. And it always gets me.
Hi, welcome to What's Up with Adam Tilted. I am Adam, and I have a special guest with me. Hi, welcome. Kim.
Hello, Adam.
How you doing, Kim?
I'm doing well.
Thanks for joining us.
Well, you're welcome. Thanks for having me.
Can you tell our viewers a little bit about yourself in case they don't know who you are, which I find unlikely, but.
Well, if you don't know who I am, my name is Kim Gaskill. I am a retired firefighter turned entrepreneur, and I spend my time these days traveling around as much as I can and learning and teaching and writing. And my handle is Ecotech, ECOTEK, a little bit of ecology, technology, and fun all mixed up together. So
Excellent. Excellent. Well, thank you for joining, Kim. I got to know Kim on Snapchat, and if you are a Snapchatter, I highly recommend that you follow her. And if you need her code, hit me up and I'll give it to you. Okay. All right. So, Kim, we're going to talk about the moon today. I'm really psyched about this because, of course, the moon is one of the easiest things to observe. And one of the things I love about astronomy is that anybody can do it. All you have to do is go outside and look up, right? And the moon is easy. You know, it's so big and bright. So, but before we get into the moon, I want to talk about some space history that happened this week. On May 31st, in 1975, the European Space Agency was formed. We do a lot of collaboration with them. NASA and ESA, and sometimes the Japanese, I think that's JAX. Forgot, should look that up. But a lot of collaboration. In fact, the space station, the Hubble telescope, the Rosetta mission that went to visit a comet, all of those were ESA missions with collaboration with NASA. So that was exciting, 1975. And then in 1965, on June 3rd, which would be this Saturday, Gemini 4 launched. And this was a remarkable launch because, of course, the Gemini program was part of the lead up to the Apollo program landing on the moon, right?
Okay.
It started with the Mercury program, and that put one person in a capsule and launched them up into space just to make sure that they weren't going to die once they left the atmosphere.
Right.
And orbited, you know. The Gemini program tested 2 astronauts in a larger capsule, and on June 3rd, 1965, Ed White made the first spacewalk by an American. So that's pretty cool. I mean, if you think how scary that must have been.
Really?
I mean, oof. You see the Earth just below. Oof. Gives me chills. I would do it, but I would be scared. And then on June 4th, this Sunday, is the anniversary. In 1974, construction on the International Space Station began. This is clearly the most complicated and ambitious engineering project that I think has ever been attempted. The International Space Station has been a great boon to science, though, because things act differently in low Earth orbit.
Right.
Something that most people don't know about the space station is that technically it's not really in space. I mean, don't tell NASA, but the ISS is about 250 miles above the surface of the Earth. That's not really that far. In fact, it's kind of still in the atmosphere. Earth's atmosphere, there's not a clear line where it stops, right? It just kind of fades away. But in that faded out part, that's where the ISS is. So
let me ask you a question. How old were you when they built the space station?
I was born in 1971. So
See, I was 15. So I remember that was a time when I was like so curious, and about the earth and space and everything. So it was very cool to grow up in that time as a teenager and see that.
I bet.
And then the whole program, so I had a little different feel maybe, as a baby boomer about the space program.
That's interesting. That's interesting. Yeah, see, I'm a space shuttle kid.
Okay.
Because by the time I was a teenager, it was all about the space shuttle.
Yeah.
And
see, it matters.
It does. That's
what age you were when, how you relate to.
Because my parents were the Apollo. They were Apollo kids.
Right.
I wonder what the next generation will be.
I don't know. Because see, Mars. Yeah.
Mars. I vote Mars. Or back to the moon. I think we need to go back to the moon. We haven't been that many places on the moon.
Right.
I mean, seriously. It's like we landed. It's like we landed in, Cincinnati, and then we think we know everything about the Earth. No, there's a little bit more to it than that. Okay, speaking of the moon, let's talk about the moon. I'm going to pop up a picture here. This is This is a photograph that I took.
Really?
Yes, using a remote telescope in Chile. I believe this one is from Chile. This is a full moon. And we're going to go through all the different phases, but I just wanted to show you some of these images that I got. In this one, you can really see those craters. And the best time, here's a little tip for the sky watchers out there. The best time to observe the moon is when it's a crescent.
Oh, okay.
Yeah, because you can see the craters, and it's even better when it's the waxing crescent on the other side. But see how you can see that detail there?
Yeah, it's mesmerizing.
Yeah. So when it's a full moon, it's a little too bright.
Okay.
And the brightness of the moon washes out the details, so you don't see as many of the ridges. It's still beautiful to look at.
Yeah.
But if you want to see the details of the moon, it's best to do it at a quarter moon or a crescent moon. So let's talk about those moon phases, shall we?
Yes, shall.
Actually, before we do that, let's talk about where the moon came from. Let's start at the beginning.
Okay.
There are some competing theories. I don't know. But the most widely accepted one now is that a Mars-sized object collided with the very early forming Earth. Massive collision at very high speeds, and boom. So the Earth split open, and all of the stuff inside flew out and started orbiting the Earth. And for a while, the Earth had a ring. And then over millions of years, those particles coalesced into the moon.
Okay.
When the moon formed, it was very much closer to the Earth. But the moon is actually drifting away from us at about 4 centimeters a year. Yes. 2 centimeters is about the width of a penny. So 2 pennies. That's how far away the moon is getting from us every year.
Wow.
Eventually, it will be so far away, in about 50 million years, it will be far away enough that it will take 47 days for the moon to orbit the Earth. Right now, it takes about 27.
Yeah.
Mm-hmm.
That's pretty amazing and kind of scary.
I know. Yeah. The moon is the object other than the sun that exerts the most influence on the Earth. The moon is unusual because it is very large relative to the Earth. Most moons are just really tiny. So last week when we were talking about dwarf planets, or before we were talking about Jupiter, Jupiter is this massive thing, and then there's this little dot of the moon, right? Mm-hmm. But our moon, the diameter is about 27% of the Earth, so almost a third as wide, and it has 60% the mass of Earth, which is pretty amazing. So we know it's not a captured asteroid because there's no way an asteroid would be that dense.
I guess I didn't realize it was that large compared to the Earth.
It is. And that causes some interesting things to happen that we just take for granted. The moon and the Earth actually orbit each other. Okay. And the moon, let me switch back over here. I'm going to show you.
Now, I know we have some people in here, and if they have people that are interested in this, you could ask them if they would share this out. Because I find this really interesting. So, yeah.
Yes, please do.
I think I saw Blake and Cindy and hey, everybody.
Oh, I was going to share it out and I didn't. So if you look here, here's the orbit of the moon. Here's the Earth right there. Okay, now I'm going to move time ahead a little bit so we get some motion. Now you'll notice that the orbit of the moon is not equidistant from the Earth. You see?
Right. Yeah.
So let me highlight the Earth so we can see it better. So it's closer here, but when it gets all the way over here, it's further away. Okay. So when that happens, when the moon gets closer, then the Earth exerts more gravity on the moon. And then when the Earth is further away, it's less. So the moon is actually kind of squishing like a ball as it goes around. And so is the Earth, which is crazy. And that's what causes the tides.
Okay.
The moon is actually causing the Earth to squish. And
so it's not really pulling.
It's pulling and squishing. So
okay.
The result of pulling on one side of a sphere is that you get a
squishing on the other.
Egg shape. Yeah.
Yeah.
So so that's the same process if you tuned in for the Jupiter episode or the Saturn episode, those icy moons that have the ice volcanoes. Mm-hmm. That's the same process. Okay. In those cases, it's Jupiter or Saturn pulling on those moons, and in this case, it's the moon and the Earth pulling on each other. Now, the center of gravity between this system is within the Earth, so this wouldn't be a double planet system, but there are, like Pluto, which we were going to talk about in a future episode. Pluto and its largest moon, they go like this around each other. And so we don't know whether that's a moon or if it's just like a twin planet system, right? Because they're almost the same size and they're orbiting each other. And yeah. Okay, so back to our moon, though. I want to show you the phases of the moon because you can, there's a pattern that we can see. All right. Let me get us to now. All right, here is what the moon looks like right now from Earth. And we just passed new moon. I don't know if you saw the moon last couple of nights, but it's been a beautiful little sliver. And we can see that here, this little crescent right there. Okay, now I'm gonna start time forward and we're gonna watch what happens to the shadow that's on the moon as we go forward.
Okay.
Okay, so here we go. Okay, we're at full moon. And getting back to new moon.
And where is this image shot from in relative to the Earth?
This is as seen from the Earth. Okay.
From what hemisphere? Does it matter?
No, whatever hemisphere is, because, you know, the Earth is rotating.
Right.
Everybody gets to see the moon in one day while it's moving. So, yeah, it doesn't matter so much. But actually, this one is tuned to Houston. I don't know if this particular part of the program, if it makes any difference. I mean, I don't know that you can really tell. Okay, so I want to show you this. This is the, wait, we need to stop. Stop. Okay. You may have heard people talk about the dark side of the moon. Mm-hmm. There isn't one. I mean, There always is one. One part of the moon is always dark, but it's not always the same part. People get confused because the moon is tidally locked with the Earth, which means that we only see one side of the moon, okay? Because the rate of rotation is the same as the rate of its orbit. So as it goes around, we're always seeing the same side. This is the other side. In this picture right here, this is the back side of the moon.
Okay.
The far side of the moon. So
Which we don't see.
Which we don't see from Earth, right? And we've got, I mean, just look at that. That is way different looking than the other side. Way different.
Yeah, totally different.
And if we think about it for a minute, we can probably figure out why. Let me move this ahead a little bit. Okay, so this is the side that we see. Okay, the other side of the moon you saw was just riddled with impact craters. Just the whole thing was just like pockmark, pockmark, pockmark.
Oh, I see where you're going.
Because remember, we think that the moon formed in the early solar system when these crashed all together. There were so many pieces of debris just flying every which way. It was a very chaotic time, 4.5 billion years ago. After the moon formed and it's orbiting the Earth, it's got that same face out, right? So as the meteors are coming in, that's the side that they're hitting the most.
Yeah.
Okay? Because in order to hit this side that we're looking at now, it would have to go past the Earth.
Right. That makes total sense. Yeah.
Yes.
You know, the people are, I just got to tell you, the people are loving this, Adam. I'm seeing the comments. And yes.
Great.
Yeah.
Great. I could talk about this all day, but we've got 15 more minutes. So
they can tell. They can tell. It is very interesting.
It is. And the more we learn about it, the more we realize we don't know. And that's one of the things I love the most.
That's me too.
There's always another exciting discovery waiting for us, and we just have to go out looking for it.
I love the wonder of things that I don't know, that I get to go explore and find out new things. When you know, it's kind of boring if you don't have anything to explore or to look forward to or a mystery. So I love it. Yeah.
Like people ask, well, why do you want to send a probe to Europa? What do you think you're going to find there? I don't know. That's the point.
Exactly.
I want to see what's there. I don't know.
Yeah.
Okay, but so back to these, this side of the moon. This side was shielded from the most part from all of those incoming meteors. Excuse me. And because the moon does not have an atmosphere, those meteors are just slamming full speed into the surface of the moon. When a meteor hits the Earth, it hits the atmosphere and burns up usually. But if it's big enough that it doesn't burn up, it slows way down before it hits.
Right.
But not on the moon. Not on the moon. Kabam. So these parts, these dark flat areas here, long time ago, before we knew much about the moon, these were called seas because they looked like oceans or lakes or something, And I can see that. They certainly do. Yeah. And they're flat, but they do have impact craters in them. So we know that something happened to cause this plane, but there was still stuff hitting the moon.
Right.
Okay. So what we think happened is something big hit the side of the moon and punctured the crust. Here's what the inside of the moon looks like now. But when it formed, this part was more liquidy. It wasn't solid yet because it still had all that heat from the particles coming together and squishing under the gravity.
Okay. And
so then a meteor would come puncture that crust and some of that magma would spill out like a volcano on Earth.
I see.
And so that's what we're seeing here. These are lava plains, basically.
Interesting.
Yeah, and it also brings up a question, are there lava tubes on the moon? We know that there are lava tubes on Earth, and we know that there are lava tubes on Mars, but are there lava tubes on the moon? And the reason why that's an interesting question is because that could be a place where life could survive. We used to think that the moon was really dry. Turns out it's not. There's water everywhere. It's frozen, and it's I mean, it's not as much water. It's a relatively small amount of water, but compared to what we thought, there's a ton of water there. And you can, if you have the right equipment, you could extract that water from the regolith and use it for drinking water, bathing water. You could use it to create rocket fuel, all kinds of stuff. So there are a lot of ideas to put a base on the moon as sort of a jumping off point to further places in the solar system, such as Mars, for example.
Okay.
Maybe you could take a rocket to the moon and then, fuel up there and then head off to Mars. It'd be a lot easier to launch off of the moon than it would be from Earth. Mm-hmm. A lot less gravity and no atmosphere drag. So I hope that happens. I think that would be really cool.
I'd go.
Yeah, I know, right?
Yeah.
Okay. I wanted to see, I wrote down, there's just a ton of interesting facts about the moon. It's obviously the only other place in the solar system besides Earth where people have been.
That we know of.
That we know of. Good point. That's a good point. See, I like the way you think.
Yeah.
Okay. Oh, this was something that I didn't know. I learned while I was doing research for this show. When the moon formed, it was much closer to the Earth, as I mentioned. Mm-hmm. And the Earth's rotation was much faster. In fact, a day was like 8 or 10 hours.
Oh, wow.
Okay? Yeah, I mean, it just was spinning. And the moon causes drag on the Earth because the Earth is kind of pulling the moon along with it as it rotates, right? And so and the moon is drifting further away. So that slowed down the rotation of the Earth to give us this roughly 24-hour day that we have now, which is really interesting because if you think, if that had not happened, life may not have evolved on Earth because a 10-hour day, I mean, that's harsh. I guess life would have evolved
it would
to
adapt.
Accommodate those conditions,
right.
But it wouldn't be life as we know it.
Like Jurassic Park, life finds a way.
Exactly. So I thought that was really, really interesting because I didn't know that the moon kind of rules the Earth and the Earth rules the moon. It's very amazing that something that is far away from us can exert that force so much that we can see a difference. We see the tides. We see.
So let me ask you this: Can one exist without the other?
Well, the Earth would be. Well, if the Earth did not have a moon, if we assume that it formed the same way, but never collided with that object to form the moon, then it would probably still be spinning that fast.
Okay.
So, I don't know. Now, if the Earth weren't here, the moon would just go into orbit around the sun like an asteroid or a dwarf planet. In fact, the moon is larger than Pluto.
The moon is what?
Larger than Pluto.
Yeah.
Yeah. So, good question. I don't know. I think that we take the moon for granted. It's just up there, lighting up the sky. But one thing I wanted to point out about when you're looking at the moon, here's what I want you to come away with. I want you to understand how the phases of the moon work. Yes.
Can you see the comment?
I can't.
Okay. Can you put that up again? There's Amy is here. Do you want to invite her in?
Oh, Amy. How are you feeling, Amy? We've got 6 minutes left, but we can invite her in if
that was the question.
If the Wizard of Oz can make that happen.
Yeah. Because I can pop out if I need to. And
no, that shouldn't be necessary. Okay. So Amy, I don't know. It depends on how this was set up to begin with, but hopefully I'll see you in a minute. Okay, so what I wanted you to come away with was the phases of the moon. You can tell the shadow and the light always move from the right of the moon to the left.
Okay.
Okay. So as we watch this go, you can see the light is going right to left, right? And then as this goes around, let me speed it up a little bit more. You see the shadow is coming from the right side to the left. So if you're looking at the moon and you see a crescent that's pointed to the left, you know that we're headed toward full moon.
Okay.
If you see a crescent that's pointed to the right, you know that we're headed toward new moon.
Got it.
A crescent pointing to the right is going to grow and grow and grow. And the crescent pointing to the left is going to shrink and shrink and shrink. Do you notice anything else about the moon as it's orbiting?
I was going to ask you, it's like tipping back and forth.
Yes.
So tell me about that.
Yeah.
Because I find that kind of
surprising, huh?
cool. Yeah.
Well, just like the Earth has a tilt, so does the moon. So depending on where the moon is in its orbit, we're seeing the side that's tilted towards us or the side that's tilted away from us. So here you see it's starting to tilt away, and then it's going to tilt back. It's going to tilt back.
So that's because it's spinning as it orbits.
It's spinning as it orbits, and it's spinning at an angle, at a tilt. It's tilted like me. It's the moon tilted.
The moon tilted.
Yeah.
How appropriate.
Which means that technically we get to see more than half the moon from the Earth, because we can see the little part that's down here when it peeks out, and we can see the little part up here when it peeks out. And I find that just interesting.
Yeah.
It's
I was watching that and I was like, okay, he said we could always see the same part all the time, but it's doing this.
Exactly.
So how far does it actually go?
Yeah. So that's one of the fun things that I like to see in these kind of simulations, is you can really see that effect. But I do encourage everyone to go out and look at the moon and just look at the moon periodically over the course of a month and see if you can identify these phases. Okay, we start off with new moon and go all the way to full moon, and then it repeats itself. And I'll do another episode on the Earth-Moon system, and I'll tell you about the names of all the different phases of the moon. But we're running out of time.
Great.
I can talk about the moon all day.
I was gonna say, yeah, I'm excited for the next one. There's
a lot more to talk about for the moon. But I do want to say some thank yous before we go. Thank you, Kim, first of all, for joining. It's been
you're welcome.
Fun.
This was very fun. Yes.
We'll have to do it again. And thank you to Bubbler Media for providing the platform. You can find Bubbler Media on Facebook for now. And if you enjoy this type of programming, you can help us by becoming a patron. We have a Patreon account set up, and that link will be put in the comments. So it would be greatly appreciated if you would help us cover the cost of producing these shows. I also want to thank Glitch Nemesis for our opening music, Love is Free. And that's it for this week. I hope you have a good week, and don't forget to look up.
Thanks, Adam. This is great.
All right. Bye-bye.